uh, are not able to communicate perfectly their ideas in English. I'm not an expert in the topic. I'm trying to read something about this. I love technology, etc. But please, I want to let you know that I'm not an expert in the topic, and there might be some parts or pieces of information that I can't manage properly. But the idea is to help them communicate the ideas in a clear way, okay?
Great.
I'm
Thank
not a
you.
professional. I'm not a professional in translation or interpreting, but I like doing this and I'm trying to do my best today. So I beg you please to be kind of patient if I forget or I don't know how to define any concept. Uh, the idea is to make it clear and they're going to make a presentation of the project. And at the end, they will have a space to answer if you have any questions to pose to them. Okay?
Thank you. Thank you for taking the time to do this. We appreciate it.
Some of you speak Spanish, maybe? No Spanish at all.
Very, very, very little. Very badly.
Maybe my English is better than your Spanish, something like that.
Much, much better. Poquito,
Okay.
poquito español.
Poquito, a little bit. Okay.
Bueno, pues agradecerles a todos por este espacio y al instructor Juan Carlos por su apoyo en esta reunión. Espero que me estén escuchando bien ahí. Bueno, igual Juan Carlos tiene buen audio allá y seguramente lo van a escuchar bien a él.
Cesar wants to say hi and also expresses his thankfulness for you being present here. And he wants to make sure that everything is right as to the audio and everything, if they're listening properly to him.
All good.
Okay, Jonathan. Juan Camilo, ¿se escucha? Nice to meet you, Jonathan. Juan Camilo, ¿se escucha?
Sí, señor.
Okay.
Hola, Juan Camilo.
Buenas tardes, buenos días, good morning.
Buenas
Good morning.
tardes, buenos días.
Hi, nice to meet you. ¿Puedo iniciar la presentación o...?
Cesar wants to know if he can start right now with the slide presentation, the slideshow. Yes?
Sure.
Okay.
Yep.
Go ahead. Adelante, Cesar.
Okay.
Can we get a little bit of background here?
Larger?
No, that's great.
Okay.
If I'm not mistaken, Sarah was in Colombia recently. She met with your group.
No, this is different. This is a different city in Colombia,
All right.
I have not met anyone.
Okay. So is there any
in
other
Cali.
background we should have? I guess you're going to do it. Okay. Sorry to interrupt. Please continue.
No problem.
Ok. Bueno, buenos días a todos. Pues ya Juan Carlos hizo mi presentación. Soy César Agudelo, instructor del SENA, diseñador industrial, y hago parte pues, del semillero de investigación que hoy les estamos presentando.
¿Listo, César?
Un guión, sí, en un momento.
Que ahí está fluctuando el audio, o sea, como que...
¿Se escucha muy bajo?
No, está con cortes, ya está mejor, está como intermitente.
Vale.
Okay, Cesar Augusto Agudelo Ferrero is an instructor at SENA. at the Center of Electricity and Industrial Automation, CEI, in Cali, Sena Valle, and he's the leader of the research group at our center in this project. As you can see, he's an industrial design instructor at Sena in Cali, Colombia. He has experience in 3D modeling, digital fabrication, and assistive technology projects. And as he said, is the leader of Research Set Bits. It's like a group of researchers focused on innovation, product design, and emerging technologies. At present, he is coordinating the development of a myoelectric upper limb processes with a multidisciplinary team of trainees or apprentices that we have at our training center.
Vengo trabajando desde el 2024 con la Universidad del Valle, acá en Cali, con la Escuela de Rehabilitación Humana y el programa de terapia ocupacional, apoyando el diseño de ayudas técnicas y pues asesorando algunos trabajos de grado de algunos aprendices interesados en el uso de la impresión 3D para el desarrollo de estas ayudas técnicas.
Okay, Cesar says that he has been working with Universidad del Valle. Maybe you have heard about that, Universidad del Valle, in different projects, specifically with projects related to the development of prostheses and the School of Rehabilitation Therapy to work on designing of these pieces to help people to recover movement, motion, with the use of myoelectric prostheses that he's been working on. Okay.
Me enteré de la red de e-NABLE buscando soluciones de bajo costo para prótesis de miembro superior, con el objetivo de dar una respuesta a un paciente en la Universidad del Valle que pues, se abordó o empezamos a trabajar desde el año pasado, desde el 2024.
Okay, since 2024, last year, he heard about the e-NABLE network because he was looking for low-cost solutions for upper limbs prostheses with the objective of getting an answer to give response to a specific case that they started working with since October last year. But only this year, they managed to set the final team for work and getting like a more solid scheme of work of the team.
Voy a hablarles ahora del equipo de trabajo de nuestro semillero, que está constituido por aprendices nuestros como John. John es uno de nuestros aprendices del programa de automatización de sistemas mecatrónicos. Y también tenemos aprendices de electricidad industrial, de diseño de contenidos digitales, de desarrollo de software, como es Juan Camilo, que está también desde Pereira, en donde pues, participan en el proyecto.
Okay, Cesar. Cesar wants to introduce his research team. As he stated before, the team is based in Cali, Colombia, and it is made up of different members coming from different disciplines like mechatronic systems automation, industrial electricity technology, industrial electrician technicians, digital content integration technician. These are apprentices or learners from these different training programs we have at Sena, okay? Electronic equipment maintenance and assembly technicians. And in this meeting, we have Juan Camilo Incapié. He's a student of software analysis and development technology. This is a virtual course we have at Sena, and he's been in charge of the programming and the software and all the connections that have to do with the servos, with the management of microprocessors, and everything related to the signals analysis and everything, okay? They come from different fields of knowledge. Some of them are trainees or apprentices who now are professionals in the fields of knowledge, and they have been working together to document, prototype the myoelectric prosthesis project.
Next es acerca de cómo tenemos organizado el proyecto. Digamos que hemos establecido, iniciamos pues identificando la información relacionada con el proyecto, ¿no es cierto? Pero para esto organizamos unos equipos de trabajo en donde hemos identificado inicialmente pues el tema de modelado 3D, un equipo para la documentación, para tener toda la documentación del proyecto, un equipo de fabricación relacionado con la impresión 3D y el equipo de electrónica que lo lidera en este momento Juan Camilo.
Okay. Cesar says the research team has been divided into 4 specific teams. Team 1 has to do with 3D modeling. Team 2 has to do with documentary, like all the administrative stuff, like papers, documentary forms, etc. Team number 3 has to do with the digital fabrication. And team number 4 has to do with electronics. Electronics is principally the field of knowledge of Juan Camilo, who has been in charge of doing this part for the project.
Okay, ahora pues vamos a hablar un poco de los avances que hemos tenido en el proyecto. Lo primero es que pues, iniciamos reconociendo los dispositivos disponibles en la red, los que estaban disponibles ahí en el catálogo. Identificamos el particular, el de Medellín, y me pareció interesante utilizar un recurso nuestro, un proyecto desarrollado aquí en Colombia para tomarlo como referencia. Descargamos ese modelo y lo que hemos empezado es a revisar las piezas y en este momento nos encontramos haciendo ajustes con los sistemas de articulación de los dedos. Básicamente eso es lo que estamos ajustando. Estamos también incorporando la parte electrónica para los motores que estamos empleando, los servomotores. Contamos ya con la mayoría de las piezas impresas en 3D, con lo que podemos empezar a hacer validaciones dimensionales y de funcionamiento mecánico.
Okay. Now Cesar is talking about the progress they have made until now. At first, they identified the information related with the project of the Bionic arm named Medallo. This is available in the e-NABLE menu or catalog. They identified this like a good project because it's Colombian, it's local, and they found it interesting to work in a local project. It's found in Medellin, Colombia. They downloaded and they also checked all the pieces. They printed out the pieces and they now made the assembly. In this moment, they are making refinements and adjustments related with the articulation or joint systems of fingers. They're working on the joint fingers systems, and also they working on making a decision on where exactly to install the servos and the electronic devices to control the movement. Now they have most of the pieces already printed out in 3D, and with these pieces, they can make validations and trials about the functioning of the mechanics of the limb, okay?
También hemos hecho un escaneado 3D de una réplica, un modelo de los muñones del paciente. Es un paciente con amputación bilateral transradial y a partir de ese escáner que queremos crear los modelos de diseño CAD adaptados a la ergonomía y a la antropometría del paciente. Este proceso se hizo con el apoyo de los estudiantes de terapia ocupacional de la Universidad del Valle, quienes hicieron se dice esto, la validación inicial con el paciente, ¿no es cierto? Y el diagnóstico, y a partir de ahí se generó estos modelos.
Okay. Second part has to do with the 3D scanning of the patient. They performed a 3D scanning of the models of the stumps of the patient, and these models were taken with impressions in cast impressions. And in this part, we counted with the support of occupational therapy students of Universidad del Valle, and because they needed to adapt the prosthesis to the anthropometry of the patient. The patient suffered a bilateral transradial amputation, I mean, in both upper limbs. Okay? Sigue, César.
Y en el componente electrónico, empezamos a usar componentes equivalentes de adquisición local, porque el modelo de Medellín pues tiene unos componentes que hay que importarlos y eso toma un tiempo. Entonces estamos utilizando unos referentes como es el Arduino 1, un sensor para señales electrocardiográficas, y lo estamos adaptando para emplearlo en medición de señales electromiográficas. Y en esta parte, pues Juan Camilo es el que les va a hablar del trabajo que se ha hecho con relación al sensor electromiográfico.
Okay, okay. As to
Any question, David? Oh, le decimos que nos dé.
Question on the previous
sí,
slide.
le hablo a la parte de la electrónica.
I had a question on
Y luego seguiría Juan Camilo. Wait, please. As to electronics, okay.
no, on slide 5. One back.
Have a question?
Yeah, I had a question on the previous slide.
Okay. Tiene una pregunta de la diapositiva anterior, César.
So
This one?
yeah, so you scanned, did you scan the limbs first and then make the mold, or did you cast them first and then scan that? I have two questions. My question is, what did you do in which order, and why did you do it in that order?
Ok. ¿Quieres saber qué hicieron y en qué orden lo hicieron y qué van a hacer? O sea, en qué orden hicieron las cosas y en qué orden van a hacer lo que sigue. Entonces, paso a paso, ¿ok?
Vale. Primero se hizo la valoración clínica del paciente por parte de los estudiantes de terapia ocupacional, y en
Para
esta valoración se tomó el modelo de los muñones, porque pues para no estar contando con el tiempo pues del paciente.
Okay. First thing they did was to evaluate by the occupational therapy students of Universidad del Valle. They were the ones who assessed or measured and made the validation, okay, for the model of the stumps. Because they have more knowledge of the movements and the physiology, etc.
Ok, luego empezamos a identificar la necesidad del paciente que quería, y él quería tener nuevamente la posibilidad de hacer algunos agarres en particular, ¿no es cierto? Asumir, entonces quería tener una prótesis que fuera más funcional a lo que se pueda conseguir acá en el mercado.
Okay. Then they asked the patient what he wanted to have. And the patient, well, they evaluated the patient's needs. And the patient stated that he wanted to be able to make some grips and to have like prosthesis being more functional than aesthetical. More functional.
Paciente, diles porfa que el paciente ya lleva 14 años con esta condición, que ya se ha adaptado, pero que él quiere volver a hacer algunas, él es un paciente de 54 años, pero quiere hacer algunas tareas pues de dibujar, de...
Okay, Cesar says that the patient has been with this situation of bilateral amputation for 14 years, and he has been able to do some simple grips, but he asked he wants to be able to do more things, to enlarge his spectrum of movements, to try to draw, for example, make designings, handle a pencil, things like that.
I guess my question is, I see on the bottom left, that looks like a plaster cast, not 3D printed.
Sí. Que hay una impresión que se hizo de yeso, ¿cierto?
Yes, sí.
So the
Yes.
first thing that happens, right, is the person goes to the prosthetist and they get a cast. Is that, and then they get a scan of the cast? Is that
¿Por qué no lo hicimos directamente sobre el paciente?
No, del yeso. Could you please say it again? It's a
Yeah,
slow
yeah.
calling here. Again, please.
so? I'll kind of explain why I'm asking first, so you can kind of phrase it better. So my question is to try to understand what the whole process looks like from start to finish. So the first thing I see is this cast. So I assume the person goes to the prosthetist, they make a cast, a plaster cast of the limb, then they scan it, then they use it to build the 3D print. Is that correct? And my
Sí.
question is, why do they make the cast? Why not just scan the limb?
Why did they make the cast?
Ah,
I can answer this.
Okay.
The point is that scanning, it's really important that the subject not move. And a plaster cast turns out to be a good way of getting a very high fidelity, stable model. And then you can scan it more reliably. And if something goes wrong, you can rescan it without inconveniencing the patient. Also, you can modify the cast or mark it in order to highlight certain key features. So the standard practice is first to make a robust cast and then work on scanning.
Okay. I would be curious if they have tried to break through that, because I've seen success. I've seen some success breaking through that workflow, because then to your, and again, Juan, sorry that we're kind of talking so much, but
No
I
problem.
totally agree that it's the more stable workflow, but I would kind of push back that it's better for the recipient, because the total time to cast is still a decent bit depending on what scanner you're using. I think, Juan, if you want to translate that to Caesar, that John.
yes, please. Thank you.
It's too much. But you want to make sure if the sequence is the right one, and our expert answered properly, I guess, that this is the sequence, and obviously they have been like testing, trying to test the model so the patient feels comfortable. The thing is, they have been apart from the patient for a long time because they don't want to be like intrusive with him, and only will ask him to come. He lives in Medellin. It's not easy for him to come once and another, and they will try to prove from time to time and make adjustments as required.
Okay, thank you.
Continue, Juan Carlos.
Sí. Es que él quería saber si la secuencia era esa, la que está planteando, que por qué escanear y luego construir. Ujú.
Ok, ok. Entonces, ¿qué hemos hecho? Bueno, tenemos dos componentes que van a ser la base del proyecto, ¿no es cierto? El Arduino 1 por temas de espacio, de dimensiones, y un sensor electrocardiográfico que estamos adaptando para captar señales electromiográficas, y un par de servos para generar pues la acción del agarre.
Movimiento.
Sí.
Ok, esa parte. Ok.
Ok.
Okay.
Es
As
Juan
to
Camilo.
electronics, see, as to electronics, they use components that are equivalent, and an advantage they found is that these are easily available in our market. Arduino Nano and an electrocardiographic sensor, AD8232, to make validations of functioning. The thing is that the sensor, the ECG sensor, can interpret only electrocardiographic signals. But Juan Camilo Hincapié managed himself to make like a filter to only perceive those signals related to muscle stimuli. This is like the key point here. Now, Juan Camilo, which is the apprentice, the learner who has been working in the mechatronic components, is the one who's gonna explain what he did. Okay?
Okay. Hello, my name is Juan Camilo. It is truly an honor to be here, and will now explain the signal processing stage of our project. In order to make the EMG signal usable, we applied a simple digital processing. First, the raw signal is sampled at 1 kHz. Then rectification is applied to keep only the magnitude of the muscle activity. After that, an envelope filter smooths the variation in the signal. Finally, normalization and hysteresis are used to robustly detect muscle contractions. In our system is detect contraction act as a trigger. It twists the prosthetic hand between open and closed states. For example, when a contraction is detected, the servo moves to 180 degrees, closing the hand and keeping it closed. The next contraction returns the servo to 0 degrees, opening the hand. And this toggle approach makes the system simpler and avoids continuous fluctuations, will still provide intuitive control of the prosthesis. Siguiente diapositiva, gracias. EMG response at rest. Here we can see the response of the EMG signal in the Arduino serial plotter. When the muscle relaxed, the signal remained stable around 300 units. Each line in the plot represents a processing stage. The purple line is the raw EMG signal. The blue line is the rectified signal. The red line is the envelope, which smooths the activity. The green line is the normalized signal used for activity. And this resting baseline is important because it defines the reference level for detecting contractions. Siguiente, gracias. EMG response during contractions. During contraction, the signal envelope clearly drops to about 50 units. And this contrast between rates and contraction allows us apply normalization and hysteresis with this method. The system can reliably detect muscle contraction as on and off triggers. As a result, the servo motor reacts without false activations, switching consistently between open and closed position, just like a prosthetic hand.
Ok. ¿Vas a hablar algo más, Juan Camilo?
No, señor. ¿Alguna pregunta o algo?
I want to know if you have any question on this.
I have a question. So if I understood this right, it's the control action is basically open and closed, fully open and fully closed. There's no in between.
Ya, él quiere saber
No.
si la operación es abrir, cerrar solamente o si hay algún punto intermedio.
Por ahora, en el proceso que vamos, estamos en abrir y cerrar la mano.
By now, they're
Estamos
only in
haciendo-
the process of open and closing.
Okay.
Estamos estudiando la respuesta como tal del sensor, es algo limitada por lo que es El sensor es para el corazón, es electromiográfico. Entonces está estudiando la señal a ver qué más movimiento se puede hacer con este sensor.
Okay, they are trying to find it because the sensor is aimed to detect electrocardiographic signals, not muscle movements. They're trying to find how sensitive it is to detect or read the muscle stimuli to find the point, the intermediate point, the medium point.
Diles también, Juan Carlos, porfa, que estamos validando con el paciente qué tipo de respuesta tenemos en sus residuales, en sus muñones, que es la parte pues, que vamos a comparar con respecto a los sensores, a lo que a lo que ha hecho Juan Camilo.
Las conexiones nerviosas, si están ahí o no, y activas eso.
Eso sí.
Okay, they are also asking to the patient, trying to find if the nerves are totally active because of the bilateral amputation. Some nerves have been maybe out of order, or that they simply don't work. So they're trying to find how operative functional are the nerves of the muscles in both limbs to check the response of the movements.
Okay, thank you.
Ok. ¿Qué sigue ahora? Sigue precisamente el ajuste dimensional, ¿no es cierto? Con la antropometría del paciente, el trabajo colaborativo con los estudiantes y profesores de terapia ocupacional para validar pues, el uso de la prótesis, que el paciente la
Calibración.
reconozca, ¿no es cierto? Y que la pueda aprender a utilizar. Y luego, pues ya mirar cómo refinar la parte electrónica, la parte del control y los servos, ¿no es cierto? Y hacer ajustes de mecánicos y funcionales en ese ensamble de la prótesis.
Okay. Our next steps will be to validate as to dimensional and ergonomical, the prototype to be applied to the patient. They will join a team of professors and students of occupational therapy and physiotherapy from Universidad del Valle, so they can validate different aspects of the uses of the prosthesis, like how comfortable it is, how heavy or light it would be, etc. The precision of movements, and obviously the movement of the servos to make adjustments of grips according to the patient needs. Okay. There also a plan to integrate different ways of learning how new iterations on the design can affect the project.
Ok, pues queremos agradecer a todos por su tiempo, por su interés en nuestro proyecto, a la comunidad de e-NABLE por todo el soporte y la inspiración pues, que brindan ahí en esa red. Y, pues dejamos abierta el espacio a preguntas o retroalimentación de parte de ustedes.
Okay, Cesar and Juan Camilo wants to express their thankfulness for being so patient, to being here, and also to be interested in this process, in this project. They are working hard on this, and now they have like an open space for you to make to ask questions, to pose questions, or to give them the feedback you consider relevant for this project.
John.
John, you're on mute.
Please.
Thank you. I said, well done, and thank you. It's particularly nice to see that the Medallo hind held up and that you've been able to take it forward. And I love that you're working with an occupational therapist and an actual patient. I hope you'll keep us posted on this. One of the challenges with these Myo devices is that, of course, there's a lot of development still to be done. And myoelectric is sort of notoriously finicky. So it'll be great to see how this does. And if the patient is able to make good use of it, and if so, if you can make it easier for other people to follow in your footsteps. I'll remind. I'm going to pause in case you need to translate, but I suspect that your listening is better than my listening.
Ok,
De acuerdo.
sí, dice que es un trabajo muy bien hecho, que les agradece y que eso, que él espera más adelante, pues poder seguir sus pasos y ver cómo el paciente pueda ser ya capaz de trabajar, ¿sí? Que es un gran desafío, es un gran desarrollo el que tienen ustedes por delante, sobre todo trabajar con el componente de la parte mioeléctrica y que tienen que será grandioso ahora al paciente hacer uso de la prótesis, que será algo muy maravilloso verlo y poder seguir los pasos de ustedes en ese tipo de proyectos.
The other thing I was going to say is that, on the hub, you can create a space. They're called spaces. And if you want to put that presentation and get a forum going, there may well be other people who would like to work in parallel with what you're doing and to
Los avances.
perhaps provide feedback and perhaps suggest improvements.
Sí, dice que está abierto también para que se pueda trabajar con otro grupo de personas que le puedan dar feedback y que les puedan, digamos, contribuir con más avances en el proyecto, que simplemente es decirle a John y se abre el espacio para eso. So they could ask you or some of you to open a space to work together with other people interested in this kind of project, right?
That's right.
Sí, eso es lo que está diciendo.
Also, this week, Eric Bubar posted in the hub a new bionic design that he's working on. Eric has been with e-NABLE for a long time.
Okay.
And I think he's going for something that may be quite robust. And I noticed it has a pretty fancy touchscreen interface. A future opportunity will be for us to make these systems so that you can mix and match controllers and devices and so on. So it might be worth looking at those two projects, which both look, yours and his, look quite promising, and thinking about how they can cross-pollinate.
Okay, so it would be a good idea to share the information where and when these events will take place. So I can share the information with Cesar and his teammates so they can join. Cesar,
Right now, it's just a post, although I guess it's also true that Vivek is likely to invite Eric to give a presentation at a future meeting here, so that'll be great.
ok, que sería grandioso entonces que se pueda integrar a este tipo de trabajos y hay un trabajo que están desarrollando en Harvard sobre un componente biónicos y contactos con pantallas y todo ese desarrollo tecnológico que es ahora, que sería interesante obviamente pues comunicarnos para ver de qué manera se pueden integrar a ese tipo de trabajo. Yo diría, César, que sería a través de esta red pues contactar a John School y ver que como el correo e integrarse con esos equipos de trabajo lo que quieras
Ok.
hacer un correo formal o algo para pedirle a él eso, ¿no?
Claro que sí, de hecho, ayer recibí un correo de una universidad en Texas, del nodo de Enable Texas, que también están interesados en articular ahí trabajo porque ellos están desarrollando también algo similar.
Yes, John, Cesar said that casually yesterday he got an email from Naval, Texas. They are expressing the interest to work on projects similar to this one.
That's great.
Okay, so
So
they
a
are
collaboration space on the hub might be a great place to help that happen and to help other people see what's going on.
sí, que es interesante entonces ver qué es lo que está pasando con el proyecto de ustedes, que otra gente se entere al respecto, César. ¿Ok?
¿No? Otra pregunta.
You have another question post to ask? Sorry. Vivek?
Yeah, I have a few questions, sort of high-level questions. So I think you answered one of my questions. So how many hands have you produced
Oh.
so far? And actually, fitted with patients, and what's the status of how much you've deployed these arms or
¿Cuántas,
hands to patients, actual patients?
cuántas manos han construido y cuántas han sido ya instaladas en pacientes y cómo están trabajando?
No, hasta el momento estamos solamente prototipando esto. No hemos instalado la primera. De lo que yo he trabajado con la universidad son ayudas solamente, férulas, órtesis y cosas pequeñas, pero no se ha hecho todavía este tipo de adaptaciones. Es la primera que estamos haciendo en conjunto, pues, SENA y Universidad del Valle.
Until now, they have only working on the prototyping of this hand. They have not installed anyone yet. They have been working extensively in other kind of support, not processes like this, but support. And they they want to, they dream on that, making a functional hand, the first one for them.
So, what is the biggest next step or biggest hurdle? Is it technical, or is it actually fitting it to someone's stump and getting feedback, or what's the next hard part? What's the hardest part?
The most challenging part for them.
Yeah.
¿Sí? César, Vivek quiere saber cuál es el paso más desafiante que sigue en el proyecto que están realizando, lo más grande, desafiante que están enfrentando que sigue.
Considero que lograr que el movimiento de la mano sea lo suficientemente adecuado para lo que quiere el paciente, lo que quiere el usuario. Si
Que se
podemos
use
lograr que abra y cierra, pero que realmente funcione para hacer agarre tipo pinza, ¿sí? Tener como esos diferenciadores es como lo... Y seguramente lograr que el paciente la asuma, ¿no es cierto? Porque pues lleva muchos años sin usar nada de este tipo de ayudas, entonces que se adapte realmente y que no se quede archivada ya en su casa.
Okay. The main worry now or challenging aspect they face is that they want the patient to be able to develop a complete hand movement, not only closing, opening, but doing like specific grips or specific movements the patient needs to perform for one side. It means to adjust the hand to patient's needs, really. And the second one is they expect the patient to adapt himself to the new hand because he has been living for 14 years with the condition he has now. So they are afraid the patient may get bored or tired and simply throw them away and stop using them. This is like the consciousness or awareness on the usage of the prosthesis for the patient. These are the two big challenges.
That is a common problem, I'm told.
That's a problem that is likely to become tractable with AI systems. The Apple AirPods, this little tiny device can, as of today, can be upgraded to do real-time language translation, which means they've got some little onboard, I think, AI chip. The whole concept of recognizing patterns of activity, like from the myoelectric sensors, as well as patterns of hand motions, like, for example, might be detected from a working hand or an actor, is actually a really good task for the kind of fuzzy pattern matching that AI systems do, rather than the kinds of hard-coded filters and actions that we have traditionally been trying to get these devices to do. It's just a matter of time, and it's probably not too much time. And I wouldn't be surprised if it enters the realm of hobbyist opportunity in the next year.
Ok, dice él que en los próximos años se puede trabajar en un enfoque que así como funcionan los AirPods, pueda hacerse una especie de filtro de señal para poder reconocer cuando una mano está abierta o cuando una mano está cerrando, que sería un proyecto de investigación muy interesante de trabajar por esa parte porque son tipos de señales que se pueden detectar y hacerles trazabilidad para poder, digamos, filtrar qué tipo de señales son las que favorecen o se leen mejor para detectar que el movimiento es de cierre o apertura también, que es un desafío también que tienen por delante ustedes ahí con ese tipo de tecnologías.
Interesante, interesante esas propuestas. Muchas gracias por esos aportes y claro, me parece que esto es para seguirlo trabajando y desarrollar ya un proyecto pues más avanzado el próximo año seguramente.
He wants to thank you all for your feedback and your suggestions, your advice. He knows that he's in front of a big project, and the idea is to keep on working hard. So, reaching the goal he has set from the very beginning of this project.
I did have one question, if that's okay.
David?
Yeah, so I guess this is kind of similar to Vivek's question, right? Vivek asked, what is the task in front? And I guess my question is, how can we help? Like, what are the gaps, right? Maybe it's just time and additional people. Maybe it's a technical challenge. Maybe it's recipients. But I guess kind of a reframing of Vivek's question, which is based on the things in front of the team, what are ways that he would appreciate some help? For example, I have a background in engineering. Maybe it's design work, maybe it's engineering work.
Sorry, David. Sorry.
Yep.
I didn't hear that.
No. So I have a background in engineering. So maybe he needs help with design. Maybe he's looking for help with testing, with recipients. Maybe he just doesn't have enough 3D printers. I guess my question is, how can we help?
Okay, thank you. David, quiere saber pues que ustedes han estado enfrentando tantos desafíos de orden técnico, de diseño, de pruebas. ¿Cómo pueden ellos ayudar? How can they help you?
Yes. Eh, importante eso. Bueno,
Very important question.
actualmente el tema de las articulaciones es como lo más crítico, ¿no es cierto?
¿En
Las
qué sentido?
uniones,
Okay.
el tema de los materiales o la manera como hago yo el movimiento con los servos, digamos que tenemos unas ideas y estamos probando, pero es como lo que quisiéramos contar de la experiencia de ellos.
Ok, sería entonces el problema que están enfrentando es con las articulaciones, digamos, las falanges,
Las uniones, sí,
las uniones, ajá.
y la manera como hacemos es que los servos hagan precisamente ese movimiento de esas articulaciones.
Okay, okay. David, the problem they're facing specifically now is with the joints in the fingers to make like precise or accurate movements of grips. And also as to the material, how flexible or how friendly the material would be. Mm, with also a big problem is about the servos, how to make them function or work just as they want or just as they expect them to work more precisely in order to like a smooth way of movement, a continuous flow of movement, not the simple open closing, but intermediate moves, yes, and turning, etc.
I think as John mentioned, working with Eric Bubar would be a great idea because he's
Working
been
with
working on Eric Bubar, Bubar. He's on the e-NABLE hub. You can just search on Eric, ERIC. Last name is Bubar, Bubar. And he's been working on
B.
AR.
Okay, Bubar.
Yep. Thanks, John.
Okay.
So he's been working on server control for quite a while, I believe. So I think he might be able to help in that area.
Okay.
Sí, que
Sí.
es buscar Bubar, que es una especie de software de control. Aquí está el email de David,
Ajá.
David Ellen Took. Okay,
Okay.
David, thank you.
Thank you,
We'll
David.
send you as many emails as you can get with questions, feedback, etc.
Okay, thank you. Qué bien.
It's great work.
Listo.
Very nice. Very nice.
Muchas gracias
Thank
a
you for your
todos.
time.
Thank you.
Muchas gracias.
Muchas
you.
Thank you so much.
gracias.
Muchas gracias.
Felicidades.
Thank you for your time.
Gracias.
We'll be looking for you, sending messages to ask for anything they want, okay? Anything they need.
Buenas tardes.
Buenas
Buenas
tardes.
tardes.
Hasta luego.
It
Bye.
has been a pleasure to meet you, and I try to do my best, obviously. Thank you. Forgive me if I've made some mistakes or if I
Oh,
stopped
no.
suddenly.
Oh, congratulations. It's wonderful. Thank you.
It was perfect.
Gracias, Juan
Thank you.
Carlos. Sí, gracias. Camilo también, muchas
Thanks.
Okay.
gracias. Bye,
Thank
bye.
you.
Bye-bye.
If you want to talk about this an alternative, I spent 10 years as an engineer in medical devices, and I would be happy to help. Oh, David, thank you so much. Mira, ya tienes, David. No hay problema en que le escribas un correo si quieres hablar sobre alternativas de diseño. He pasado más de 10 años como ingeniero en dispositivos médicos y me gustaría conversar contigo. Entonces, ahí está, César. Cualquier cosa, pues con mucho gusto. Ahí nos vamos hablando. Está cerrado el micrófono.
Sí,
Ah, no.
vale, Carlos, muchas gracias. Se estuvo bien,
Bueno,
¿no? Estuvo bien todo.
sí, sí, estuvo bien. El próximo lo preparamos con más perrenque, con más tiempo
Sí,
y le hacemos
más
las
tiempo.
transición y todo. Pero no, al final no fue bien.
Y lo hiciste muy bien, Juan Camilo. Estuvo bien.
Ah, muchas gracias. Ahí
Sí.
me tiré el ruedo, pero gracias, gracias.
No, bien, bien, te felicito. Vale. Chao, pues. Feliz almuerzo a
Vale.
todos.
Hasta
Igual,
luego.
vale.
Gracias.
Recuerda guardar alguna captura de pantalla de esta reunión, porque le
Ahí,
sirve a Juan Camilo para evidencia, a nosotros también. ¿Tienes allí?
sí, listo, ya.
Aquí también tomé una, por si acaso. Ahí te la voy a poner al WhatsApp.
Dale.
Bueno, tu gusto.
Mente, gracias, que estén muy bien.
Tendríamos que para eso, si te parece, César y Juan, crear un grupo en WhatsApp, una comunidad pequeña ahí, bueno, para que no estemos aislados y
Sí,
cualquier información compartirla por ahí.
sí, sí, sí. Sí, de pronto te
Sí, sí,
integramos
sí.
al grupo que tenemos del proyecto.
Ah, bueno, vale, vale.
¿Vale?
Mucho gusto.
No, vale, gracias. Que estés bien. Chao, chao.
Y si hay que
Ah,
hacer, perdón, lo último, si hay que hacer un reporte, un informe, me dices y me avisas para podérselo pasar a la subdirectora, no sé, de pronto pide algún avance o a José Fernando, quien lo pida. ¿Ok?
sí, 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 quiero hacer eso. Quiero hacer una especie de